right, guys, so today we're going to talk about our second form of a line, which is called slope-intercept form, and how it works. And what we learned yesterday was about point-slope form. So remember, to draw a line or to write an equation of a line, you must have two things: a point to start from and a slope from that. So we want to investigate kind of what this looks like. So in point slope form, you are given an equation like this, where your point comes from what's inside with your x and what's with your y. So our starting point was positive 3 down 4, which we see right here is our starting point. And then using our slope of negative 2, we went down 2 and ran 1 over. And then you could create more points along your line if we reversed our slope and we went up and over to the left. Now, what I want to talk to you guys about is the fact that you can actually take point slope form and create a new type of form of our line. And let me prove that to you right now. So if we were to notice these parentheses and this negative 2 out front, we can actually do what we call distributing. So negative 2 times x ends up giving us negative 2x. And if we take negative 2 times negative 3 on the inside, we get a positive 6. Now over here on the left side of our equation, we still have y plus 4. So we just distributed. Now, we can also do a second thing, which is to undo this operation of positive 4. So we undo that by subtracting 4 from both sides of our equation. And what you do to one side of the equal, you must do to the other side of the equal. You got to make sure you match them up so it's a number and a number. So those 4s will go away. And guys, we end up getting y equals negative 2x, and 6 minus 4 is positive 2. Now, this is kind of interesting because on our y-axis line, do you guys see this point up here at positive 2 on our y-axis? I think that guy is our y-intercept, where we touch the y-axis. That's interesting. And then the negative 2 is still our slope, of which we're going down. We're going down 2 over 1. That's kind of interesting, okay? Will that work every time? So let's take a look at this example number 4, using this point negative 6, positive 1. And we use this slope of rise 1, run 2. So let's take a look if we can distribute that, undo our operation, and then combine some like terms here. So let's take a quick peek. So when we go to distribute the 1/2, we get 1/2 x, and 1/2 of positive 6 is positive 3. And we keep our y minus 1. And now we undo our operations here. So instead of subtracting by 1, we're going to add by 1 on both sides. Now when I do that across my equal here, we get rid of that 1 on the left, leaving us with y equals. We should hopefully still have that slope of rise 1, run 2 with our x right beside us here. And we should have positive 3 plus 1, which ends us at positive 4. And guys, when you look at the graph and where I touch my y-axis, I'm literally up at 4. That is my y-intercept. Oh my goodness, that's pretty cool. So I'm going to make a quick little note there that this guy is our y-intercept on our graph. And our slope still stays the same, that we're rising 1 and running 2. So little did you know, you actually just created what we call slope-intercept form. Slope-intercept form has a slope that goes in front of x, so slope is m, and your specific point that you're using is what we call the y-intercept. Now we call that plus b inside the formula, but you just need to know that this guy is your y-intercept on your graph, your y-int. All right, so let's take a look at how you can write these equations. Now, if I give you 2 points, you're going to have to do a little bit of work to get it so that you can give me the slope-intercept form. First things first, you need to have a slope between these 2 points, and you must choose one of those 2 points to use. So let's figure that out. So we get a slope of 2 from our rise 6, run 3, either from your formula or from counting. And now we get to pick one of those 2 points. So you know what? I'm just going to pick that first one. Why not? So if I'm using -1, 4, that means I have x minus -1, which becomes a positive 1 inside with my x. And we have y minus 4 on the outside. Now, this is point slope form, guys. So we need to change this so that we get it into slope intercept form, where we can find the y-intercept of our graph. So how we do that is we distribute through our slope. So 2 times x is literally 2x, and 2 times positive 1 is plus 2. And we keep our y minus 4. And then we undo that operation of minus 4 by adding 4 to both sides of our equal, which ends up leaving us with y equals our slope of 2 x, oops, and then 2 plus 4 ended up giving us 6 at the end. So literally our y-intercept will be up 6, and our slope is still going to remain as 2x. So our slope-intercept form is y equals 2x plus 6. You're done. So remember to go from point slope form into slope-intercept form so you can find the intercept, the y-intercept. You distribute your slope through, and I undo the operation with y, and I combine my like terms. And that ends up giving us the y-intercept. All right, so let's try that again. We should get a positive 1 as our slope since we went down 2 and divided by another down 2 motion. So positive 1 is our slope. And now you can choose either one of those 2 points. This time I'm going to choose the second one just for giggles. So we have y plus 3 equals 1 times x plus 4 in parentheses. And that's using the second coordinates to put in my point slope form. And now we need to change it so we can find the y-intercept. So we need to distribute. So we get 1x plus 4 when we distribute. We're going to undo this positive 3 by subtracting 3 from both sides and combine your like terms of 4 minus 3 to get positive 1 over on the right. So that means our y-intercept is positive 1 and our slope is 1. Now, instead of writing that as y equals 1x plus 1, you could write that as just y equals x plus 1 if you'd like, and that would still be acceptable. All right, now let's do another one to just keep this consistency going. So find me that slope. So we distribute our slope of 4 over -5. So -4 over 5x. And -4 over -5 times -5 would give us a positive 4, or 20 divided by 5, which is 4. And then instead of adding 5 to both sides, we undo that by subtracting. And 4 minus 5 would give us a y-intercept of -1 in our slope-intercept form. So what happens if we give you a graph? How could you find me the slope-intercept form? Well, remember, I need number 1, a slope, and we need the y-intercept. So what is the slope between the 2 points? Well, let's see how much we rise and how much we run. So in this first graph, we went up 4 and we ran 3. So our slope is 4 over 3x. And now we need to pay attention to where do I touch my y-axis line? And it looks like this point right here, which is down 1 is our y-intercept. So instead of the plus sign, we're going to make that a down, a negative 1. And that's going to be our slope-intercept form. It's that simple. So let's try it again from the graph. We need our slope and our y-in. So it looks like we went down 4 and we went over to the right 1. So our slope is down 4 over 1x. And then our y-intercept on our y-axis, we literally touch up at 1. So plus 1 is our y-int. One more graph to kind of get us going. Uh-oh, SpaghettiOs, I don't have any points on there. Well, if I don't see any points, guys, you can literally pick a point along those line or along the line. So I'm just going to pick 2 points just for giggles. Let's just do these 2. Yes. And now let's talk about your slope and your y-intercept. So we do not go up or down any between these 2 points. So no rise means 0 rising. But we do run between them 7 spaces to the right. So 0 divided by 7, is that 0 or undefined? You got it. It better be a 0 slope. Okay. And then we need to find where is our y-intercept. So we're going to follow our y-axis line until we touch our line. So we went down from 0, 1, 2, 3. So negative, not positive, 3 is our y-int. Now, guys, there's another way that we can write this line. Instead of saying 0x, 0 times anything, 0 times 1, 0 times x, 0 times infinity, 0 times anything is still 0, which means another way we can write this equation is no x, meaning 0 minus 3, which means that our y equals just negative 3, is another way to write that. So instead of writing 0x, you literally don't put an x because there are none. And then you leave your y-intercept in the equation. So y equals no slope, 0 slope, minus 3 for our intercept. All right, guys, it's time to practice. You have a worksheet to do today, and let's get some jamming going.